Hi everyone. Welcome to second stream of this channel where we look at AI research for Dungeon Crawl Stone Soup. So tonight I thought that we would. So I've made an agenda to go over for stuff to work on, and I wanted to just start out with a little bit of a discussion about why I'm doing this. So this project started a few years ago, and the number one reason I think is that it's fun, but I think that there's really substantial benefits for the AI community for this domain. So the fact that we want to have a complicated game like Dungeon Crawl Stone Soup that's partially observable, there's stochastic actions. There's a lot of information. It's difficult for humans. I think that's interesting. A lot of AI research is inspired by, humans. The most intelligent creature we know in the universe is a human. So if we want to make intelligent software, a lot of the inspiration has come from humans. So the fact that it's difficult for humans is interesting. And the fact that one of the goals of the API is to build a feature vector representation and a planning-based or a symbolic logic-based representation, that's really interesting. You don't see that very often, really. And also these kinds of games, so Facebook AI Research last summer released an API to NetHack. It's just visual, so it doesn't provide the same kind of state representation that we're providing here. And NetHack is a different game, even though it is in the same genre. There are some features in Dungeon Crawl Stone Soup that make it interesting that it's not NetHack. But even so, they couldn't solve NetHack, right? So it's an open research problem in the AI community. And so, and I think streaming over Twitch is going to make it fun. There's some content, so I think it'll be helpful for anyone who wants to pick up the API later and use it in their own research. It will hopefully be interesting to them and useful. So it'll show them, how the code was designed, and and also I kind of hope it's entertaining and other stuff. So, and also I just want to say that this stream is meant to be super informal. So I'm someone who has a background in artificial intelligence research. I know that some of the people here may not have any background. Maybe not even in programming. And so, let alone like AI research. So if you have questions about AI or just want to chat about AI, I want this to be informal and for anybody to be able to ask anything in the chat. So with that, let's go ahead and get started. It's always fun to see stuff moving on the screen. So just a little bit about why I'm doing this. I'm gonna go ahead and mark that as done for the evening. It's good to keep track of your accomplishments. So last time we ran into, before I get started with all that, over the weekend I had pushed a new update to the master branch, and so the README is different, and feel free to follow along if you want. So this branch is the branch that I'll be working on. This one Twitch stream with today's date, I'll be working on that tonight. And so just to check we didn't break anything, and to get started with watching the agent run, excuse me, we're going to go ahead and run. So we'll go to main.webserver.py. We'll hit run. And I think this is just kind of straight from basically the master branch. We click here, we can watch the agent. Oh, this is an existing game. So this is something we're going to have to change later. For now, I have to manually log in and exit out of a game. So I've done that now. So now when the agent starts, it'll be fresh. We can click this to watch the agent. And let's see what happens. So hopefully this didn't break anything. The agent can move around, etc. All right. Looks like things are working. So excellent. All right. So I've also committed this file that's going to show what we're working on. So you can follow along with this also. This is under the contribute folder, which if anyone is interested in contributing, I would suggest read this. It talks a little bit about the longer term research vision, some of the research long-term goals for this project. And I'm, all about supporting anybody to help out with this project. So my vision is that in the future, there'll be a lot of AI publications that can use this domain. Maybe that's a little ambitious, but we'll see. So, okay, one thing that happened last time is the agent started and there was smoke, and we didn't have smoke at the time. So we have a game state file, and we get information from the server, and then we can set things like this. So that we're looking at cells, saying that this cell has a wall, maybe it has stairs, if the player's at this cell, if there's a closed door, etc. There's lava, statues. This is all important for the agent. We want to have this information in our state, but we don't have anything for smoke. And one of the things is that, and this is a little bit of a design issue, we do not have a way to, what's great here is that we want to be able to say, if G hasn't hit any of these conditions, we want to say something. So, what's really nice is to do, in other programming languages, you would do a switch. Here, you could just do a chain of if-elses. But then here we have some special code, right? So we're saying if the player's here, but if the player's not here, it's false. And this is because there's actually multiple places where the player's location can be updated. And we just want to make sure we're cleaning out things. So, this else condition is a special case. And if we didn't have this else condition here, we could nest all of these together in a giant if else. And then we could have like a default clause at the end, which just says if you didn't catch anything here and there is something here, it means we need to add something to the API, which we'd love to have. So I'm thinking this is a special single case. Let's take this off, right? So this is basically saying the same thing about this else is saying if, I forget in the order in Python, I think we can just do if not self.g equal the @ sign, right? That's equivalent to an else here. And is this gonna complain at me? No, okay. So what we can do is we can just add this at the end, right? It's a special case. We could add it anywhere, probably actually. So let's go ahead and just add it at the end here. And maybe we'll add a little comment, just player location is updated in multiple places. So, remove old player location just in case. That's what this line is for. Okay, so now what we can do, and this is gonna be super helpful. So now what we can do is we can chain these together. So we can do all these if-elses, and then we just change them into else if statements. So now they're all linked together, and let's see if we can get some. Okay, it doesn't mind that white space. So that's all of them, and now we can add an else here, right? And this is the last. This is if none of the G values matched, then this is going to happen. So this is where we want to print a message saying we have found an unknown G. So print found an unknown G value, and let's print that out. And so here we're just gonna do self.g. Yeah, self.g. And then we'll just time.sleep, right? Because if we hit this, then we're gonna want to know. We're gonna want to see what it is. Let's do a little longer than that, 20 seconds. And this way, we'll come back into the code and make the change. And so I think this shouldn't change anything. So let's go ahead and rerun the agent. So you can't see it. I'm logging in as an admin. Sorry, not as admin, as the agent itself through the browser, a separate browser, and just quitting the game there. So I explained in my last stream. If anybody wants me to explain that, I'm happy to do so. So let's run the agent again. And if we get lucky, there would be smoke here that the agent would encounter. And then we'd see what that symbol is for G. And then we'd be able to start processing smoke. So found an unknown G value. Oh, the dot. Interesting. Well, so let's look at the, we're not drawing the map. Okay. So it's already proving to be useful. So I know that a dot sometimes means a corpse. So I'm surprised to see it here, though. You know what we want to do? I think we want to print out the state of the game in the beginning here. So we go to main web server. So we've already sent the setup actions. So before we, can we print this earlier? This is a good question. Can we? Well, we can try to print this earlier. It might complain. Let's see if we can print it here. Oh, we don't have the games. Yeah, I don't know if we can get the game state. I don't know if it's been fully loaded then. Yeah, I don't want to do that. So basically, if you remember, so these actions here are being sent while we're in menus. And then once the agent is loaded in the scenario, then we're calling this function to get the game state, because by this point the web server has sent over data about all the tiles and everything. So I don't think it'll work if we do it earlier. And so, a dot is kind of a special case. So I'm just going to ignore it for now. And I think, so I want to find self.g. Okay, we're back here where we were. And then I also want to know what cell we're at. Yeah. So let's just go ahead and add a else self.g. This found a G value of at X. Let's see. Hopefully this won't break. I know. So basically, different values here are being set at different times. So I'm worried that there might not be an X and a Y value here, and then it would complain at us. It would say basically it's none. Well, if it's none, maybe it'll just print none. That'd be great. Rather than causing a runtime exception. So, okay. Let's do this. I'm going to log in as the agent, exit out the game manually. That is one of the things, if we have time, I'd love to try and fix so an agent can just reconnect. Let's hit play. And let's see. Okay. Watching the agent go. Let's see if, hopefully this G being a dot value. Found an unknown G value, exclamation point. Right. Oh, yeah. A dot means empty space. It just means just an open tile with nothing there. So I think let's make a note. So let's follow the style we've been doing. So a dot means that it's an empty tile. Because in the ASCII representation, I think shows them as a dot. And we'll confirm that when when we are able to start drawing that. Oh, so it is running now. It's just a little sleeping. Yeah, right. You see all these are dots. That's just means it's an empty open tile. So an exclamation point is a potion. Excellent. So we have not added potions yet. So let's go ahead and do that. Oh, this is so useful. Started out to detect smoke, and looks like we'll be able to fill in a lot of things in the state representation. So self dot has potion is a new thing we're going to add here. Now I know potions can be unidentified and identified. Not going to worry about that yet. We'll worry about that later. So for those of you who aren't sure, are new to Dungeon Crawl Stone Soup, basically the potions, they have scrambled letters as a name. And then only after you drink them, or if you use a scroll of identify, but usually you don't have that many scrolls of identify. So the only way to know what a potion is to drink it, and some potions have negative effects. So it's makes the game fun. You're kind of surprised. And what's just the most fun is when you're in a dire situation. It's very critical if you have a potion that you don't know what it is. If it's the right potion, you drink it, you get lucky, it heals you, or it makes you really fast, or other things like that, and it might help you survive. But sometimes it is like a potion of degeneration. It like lowers all your attributes, or it makes you confused, or other things, and it ends up being losing you the game, basically. So it's just a fun note about some of the gameplay there. Okay, so self.hasPotion is going to be equal to true. And what we're going to do here is we're going to take self.hasPotion, and we're going to add it up here with the attributes. So we're going to make this to be, it's going to start out to be false. And then a question mark, if you remember here, so this was a scroll. And I don't know if we have that either yet. Okay, so, and what's cool, so now that we have potions and scrolls, we can actually have goals related to potions and scrolls. So we can tell, normally human players, at least in the early game, they pick up potions and scrolls whenever they can. So that's something we can add now that we have this value. So we have to go back and add it in the startup. So just so you guys, we're in the cell class. So this is for an individual cell. So we'll set this to be false. And excellent. So yeah, scrolled a little too far there. Okay. Yeah, that is just excellent. We'll still need to add some stuff later to make sure this gets included into the pddl and other state representations. But for now, we can at least process it. So excellent. Okay, well, so if we go to our progress file, we've added the code to catch new G values, and as you saw, we've already caught some and updated the code. So already been a big success. Going pretty fast here. So yeah, maybe we'll be able to do some cool things later. Okay. Found an unknown G value. Right. So you see this. Okay. I'm curious. So that's a wall or a door? This looks like, or wait, where's the player? The player's here. So I want to see what this teleport trap is and the dart. So I think the parentheses. Okay, well, you know what? So what we're gonna do is we've added this new code. We're gonna let's run it, because that way we can, as we come across new things, we can it'll trigger our collection thing for G, and we'll be able to find out. We'll be able to add new things, right? Like the teleport trap or the needles. So just run the agent. And, I usually, it's probably like a habit from early versions of the code, but I usually wait a second or two before I click on this. You click on the agent. So I think when you click on it, you become a spectator, and that's causing all this red code. Or this is just like the browser over the WebSocket because when you're spectating, you're also kind of connected via WebSocket, and so there's some data being sent because of that. So let's make sure we're okay. So far we haven't found any unknown G's yet, G values, because it'll pause. Okay, so that's running. We know we need to add a few things. So just preemptively here, let's go back to let's go back. And for those people watching, if you guys have any questions or curious about anything, want me to explain anything even from the very beginning, please feel free. So all right. So let's not worry about that. So let's go back to gamestate, and we know that we're going to have a teleport trap. So, yeah, let's do, I'm not sure what data the web server is sending over. So let's do teleport trap for now. And let's also do, there's a lot of items. So far, has potion, has scroll. These are items. I think what we're going to have is like a has multiple items, because sometimes there are multiple items on a tile, and what you'll see is you'll only see the top item. So I'm not sure what kind of data the web server is sending over from that. So we're going to have to just wait and see once we get to one of those circumstances, which we will at some point. And I'm just going to, just for a note, because we haven't done this yet, I'm just going to, just so we know, teleport trap has multiple items. And I think, I don't know. So, the thing here is that we're getting data from the server in the form of like ASCII, like an ASCII map, right? So if you play the game in the terminal, this is literally what you see, and that's how the game is represented behind this visual, like tiled version. So basically, these different symbols mean different things, and different items have different symbols, and I'm not sure. So for example, there's multiple different types of like axes. So I don't know yet if an axe, anything that's of class X, like an axe to chop or something, like a two-handed axe, if all of those all have the same, like ASCII identifier, then I'm just not sure at what level we'll distinguish them. So we'll just have to wait and see. And okay. So anyway, what's going to happen now is that this is going to pause whenever we find, it's paused there because I clicked on it, but it'll pause whenever we find a new G value, and then we can come back and handle it. So I'm going to move on to the next thing we're going to work on. Just to make this a little clear, we'll just make this all caps. So this is a fun one. So better monster goals. Oh, we found an unknown G value. Excellent. Right. Okay. So it looks like the needles that we found earlier were also giving us this symbol, this open left parenthesis. So what that means is, I think it means like quiverable item or thrown item. So I'm not sure. So I haven't looked at items, and I must confess, I'm not an absolute expert at this game. So I've probably started 500 games, and that's because some games end, very fast. I've only beat the game 3 times. So there's, I'm not, there are people that know way more about this game than myself. I'm also not a developer on the game itself. So I'm just kind of coming from this as I found the game, is open source, and I'm just looking to use it in AI research and what we need to do to support that. So that's also why the name of the GitHub repository is named as a wrapper. So it's just meant to wrap around the game and provide some extra functionality for, AI agents to play the games themselves. So all of that being said, let's go back to game state, and we have, right, so we got this open parenthesis for both needles. So, okay, you know, I had taken some time to go to the wiki and look up item properties. So these are all the ones from the crawl wiki, which if you just Google, you'll find it. And, okay, so there's thrown weapons, but brands. So a brand is like whether it's exploding or it's flaming or it's poisoned or things like that. Then there's needles, but we saw needles and, you know, I'm just gonna say thrown item or item for throwing. Has item. I'm just gonna say has throwing item. This might not be the best. We can come back and change it. And then now we know, can add it here. So else if self.g equals left open parenthesis, self.has throwing item is equal to true. Excellent. And yeah, we'll see if maybe it'll find another item. If it keeps getting stuck on this, you know, we'll do it and run again. So, okay, back to where we were before that came up. Better monster goals. Yes. Okay, so right now, you know, so I guess before we do that, so I'm going to stop this agent because I think this is just the random agent. So if we go to main web server, yes, we are currently using the random agent. So I'm going to switch to using the planning agent. This is an agent that generates goals to, you know, explore more efficiently. It will choose to attack monsters directly. It is very rudimentary, and that's actually what we're going to work on. And it will also try to go to the next level at some point, walk down the stairs. So let's just go ahead and set things up for the planning agent. One reason this is good for our own debugging purposes is that it will explore more of the game, more of the level faster, and then we'll be able to see if we find more G values that are unknown. So let's go ahead and hit play. Oh, you know what? We didn't die in the last game, so I need to log in through the web browser as the agent and just reset that character. And if you want to follow along and you're not sure how to do that, the README on the master branch should explain. But I can answer questions too. So, okay. Let's hit play. Let's see if it works. Unknown G value, money. Okay, awesome. Well, this is just highly productive. So self.has gold. It's all gold. There's only one type of currency in the game. So go ahead and add that here. Excellent. And see, the text message here does say found 5 gold pieces. So it would be ideal to say how much gold, but let's not do that for now. Figure out how much gold. Information is at least in messages. So messages refers to the text down here. That's okay. Unknown G value G, right? So a G is a goblin. So we should have monster. Unknown G value G. So I had added some code in here before to take care of monsters. There should be a monster value, but then there's also, this G means goblin, which is this goblin right up here. So Yeah. Well, if there's a G there, that means there's a monster there. So what I want to do is we have this monster class. So what I think is a somewhat decent way of doing it, just to start out with, is let's have a static, like kind of variable that represents all possible monster G values. Because if it is a monster, we want to do special things. Monsters are a special kind of thing to be on a tile, right? It's different than an item. So let's make I don't know. I'm going to call it possible G values. So all possible G values for monsters. And I know that G is in here for goblin. I'm pretty sure R is rat. And okay, let's see. We got a bat here. What's a bat? Unknown value B. So we know B is in here. So let's, yeah, we're pretty sure R is a rat. So we'll leave this, and then this is like static, right? So we can just refer to this. We don't have to have an instance of the monster class. We can just call it, directly because it's static, or refer to it. So let's go back to here, right? And now in G, we can check all these things, and then I guess we can do this in the beginning. We can say if self.g is in monster all possible G values, then self.has. We're going to say self.has monster is equal to true. Now, it should also be, so if there is a monster in a cell, there should also be data from the WebSocket in the form, so basically we get JSON data from the WebSocket, and it has all these, it's a dictionary, right? So the key, so mon is a key that should show up with all the data for the monster. So, and okay, K is another monster. So let's go ahead and add that to the monster class here. All right, so, okay. And you know what? Just to be helpful, let's add comments here. So, goblin, bat, rat. This will just help people later who are debugging. Cool. Okay. We'll probably add more of those. And self.monster. See, this variable is actually set to like a monster class instance. So I just want to say self.hasMonster. Yeah, let's just do this. Because, this agent that we're running right now, this planning agent, this agent has planning and goal selection for monster. So monster data is being written to the pddl. Okay. Self.has monster. This should be set as false. Self.has monster is false. Okay. So let's go ahead and got an @ sign here for the player. Here we're checking this, and we're just saying self.monster has true. So this will just allow us to check all of the monster values. Okay, R is in there, right? R is the rat. Okay, excellent. So let's rerun the agent, and this should allow us to, now it should no longer say we need new G values for those. And we'll be able to find other things and add them. So. All right. Unknown G value, that. Okay, so in this game, it's a, I thought that's a shaft, I believe. That is a shaft. So let's see if it walks. There's, yeah, right. I think there's trapdoors and there's shafts. So self dot has shaft is equal to false. And now we know that symbol is the up arrow. Self dot has shaft is equal to true. Yeah, shaft. Okay, awesome. So we got a shaft. Okay, let's see what else the agent. Right. Okay, so there was a sword, right? So I wonder what the sword looked like. So this is the shaft. Okay, so it's a right parenthesis item. I don't know what that is. So is it a weapon? Let's just assume it's a weapon for now. Self dot has weapon equals false. Has weapon item. Because if you remember, an open left parenthesis was, an open left parenthesis was a throwing item. So scrolled a little too far there. Right, this is a throwing item, so and just for current debug purposes, let's just print out. Okay. So that'll, because I'm not sure if the right parenthesis will, if those will only be weapons. Maybe it'll just be kind of all items. So we'll kind of just have to see. Okay, I found an unknown G value B. Surprised to see that. I thought we put. Oh yes, got it. Okay, mistake. So needed this if else. This is part of the chain of if statements. So let's go ahead and stop this. We added those. Let's rerun the agent again. Quit that game. Okay, hit play. Let's start a new game. And okay, cool. It's running. Okay, so we added some new G values. So far, it's not finding anything new. So we're going to go back and we're going to work on the goals. Right, so we wanted to have better monster goals. Okay, so this is in the planning agent. So if we go to agent, let's go ahead and so get first. Okay, so actually, the first thing is, so this is going to be a little bit involved. So what we're going to do here is we're going to go to, okay, so this is kind of involved, and what this is going to entail is we need to separate move and attack actions into move and attack. So we want to have two separate actions. And so the reason is that we want to say that when we attack a monster, that we have a chance of killing the monster. And so we want to have an effect of the attack to be to kill a monster, but we don't want that effect to be the same for movement. So it just so happens for melee in this game that movement and attacking is the same. Key press a lot of the time, but we want to have a separate model for that, for the AI agent. So we're going to do that. So we're going to make the attack action have an effect where the monster, basically the monster is dead, but it's not so much the monster is dead. I mean, what happens, right? The monster is gone. So the monster is gone. Should we say the monster is let's say it's no longer at that tile. I know that might not be perfect, but we don't want to fully solve things here. So mostly what we're doing now is we're just building a slightly better agent to play the game more and more progressively. And in doing so, we're building out a slightly more feature-rich planning domain model, and we're also able to just have an agent that can explore more of the game automatically, and then that's how we can iterate to find new features we need to add to the API, basically. So, okay, unknown G value H. Interesting. Where is the H here? The H is right next to the player. So, but it looks like we had already sent that action to move southeast. So if we did move southeast and H stayed the same, that would have meant that H was a quokka, I think. And yeah, but I think we killed it. So let's go ahead and add that. It's definitely a monster. So we're going to add that to the gamestate.py class. All right. Doing work. Welcome. Looks like we have another viewer. Feel free to ask any questions or, just ping me if curious about anything. So right now we're looking at these monsters, and we want the API to be able to represent all of them. And so some of them are new. So we basically get these symbols, and we want to find the symbol. So let's see here. Right, we want to add an H, which I believe is the quokka monster. So let's do that. And okay, there's also this. What is that? Is that a corpse? So you see this G value here. This is an unknown one that it's not supported yet. So we're definitely going to want to keep that. But this is where the player is, and this is the ASCII representation of the game. So now where is this? It's all the way up here. I'm not sure what that is, if that's a sleeping monster or what. So yeah, we're gonna have to figure out what that is. Looks like our player's gonna die here. I mean, it's really tough. For a Minotaur, you never know. They're just so beefy and they get that extra attack. But unknown G value L. Huh. Okay, well, I don't think that plus sign, or is it a cross? I'm not so I'm not sure. I'm not sure what it is, but what we do know is that I'm pretty sure if the player's here and there's 2 tiles down, I think it's a corpse. I think it's a corpse. I'm gonna say corpse. Maybe, you know, so if you don't know already, the corpses are important source of food. You can chop up bodies and eat them, and sounds gross. That's just a mechanic of the game. Hunger is a part of it. So yeah, I'm gonna just go ahead and say that's a corpse. Self-dot has a corpse. And you can die of hunger, so this is a real thing we need to handle. Yeah, so let's just go ahead and put this here. All right. Self-dot has corpse. And yeah. So we got that, and then there was L and W. I'm pretty sure these are monsters. But you know, I'm not sure. Let's just wait on that. Wow, it's still well. I mean, it's been pausing a lot, but so okay. Where is the L? So the player's here, and there's an L all the way to the left of it. Looks like an L is a frilled lizard. So we're gonna add that into the monster class. So an L is a frilled lizard. So now it will detect L's. And then what do we got here? We also got a W, right? So the W is just south. So the agent was here and the W is there. So I'm pretty sure the W is the worm, right? That makes sense. Most of the monsters have ASCII values that are close to their names. So we got a worm. All right. A lot of improvements tonight. So let's just wait and see if the agent dies here. Okay, now we had gone back over to, we're gonna work on the planning. Oh yeah, so going back to here, the progress. So we want to have attack actions that have an effect where the monster is no longer at that tile. This will allow us to have separate goals for attacking versus moving. And what this means is we will have shorter plans and more plans, and it'll just be easier to know what the agent's doing at any point in time. And I think then we'll just need to make a separate goal. Let's just say we actually want to add attack monster goals into the goal selection part of the planning agent. And, you know, I'm just in case folks do want to follow along, I'm just going to go ahead and push this now. So we're going to say we added some code to handle more G values for tile representation. And we are updated the progress log. Cool. Push that. And then, yeah. Okay. Wow. Still alive. See, this is incredible. And we haven't even given it the ability to go berserk yet, which is just makes it so strong. So, okay. We're going to leave the agent running. So now this is all pretty clear. Okay. So let's go to our planning model. So this is the pddl file we have. If you're not familiar, this is, for automated planning domains. And we have monster at. So what I think we want to do is, so this, all of these look like movement actions. So all of this or attack, I'm going to remove. So we have 8 movement actions right now, move or attack. So how many we got? Southeast, northeast, southwest, northwest, east, west. Yeah, okay, so we got all 8 here. So these are just going to become movement actions. And you know what, actually, for all of these, let's see if we can just, I wonder if this will line up correctly. We're going to add a precondition that there's not a monster there. Yeah, let's go ahead and add a precondition. So not monster at, and I think we're just going to say destination cell. Let me just check the predicate at the top here, monster at. Oh, that's simple monster information. I think we just want to have has monster. So has monster cell. Just want to have that. And again, so I'm not too concerned about having this file be absolutely perfect. Nothing like that. I actually think that some of the really cool AIs will actually be learning this model, which I hope so. This is just something that's useful for us now. So what we're going to do is so everywhere we had and not monster at, like this. So 2, 3, 4, 5, 6, 7, 8, because we have 8 actions. So we're actually just going to say not has monster, and we're going to say the destination cell does not have a monster. Close that up. And actually what we should do is just to keep things a little cleaner, we should put it here. I like having the direction at the beginning. Just a housekeeping thing. Okay, so if there's not a monster at the destination cell, then you can move into it. Just like we're checking if there's not a million other things. And so now we have all these move actions, right? So now what's cool is, I think what we're going to do is we have this action move north, or move for all these directions. We have opening doors. Let's, at the bottom, we have rest and long wait. Let's add attack north. So actually, let's say melee attack north. And what we're going to say here is actually we can only attack north if there is a monster in the destination cell. And if there's a monster, and if we're going to attack, we're not actually going to move into that destination cell. So we don't need to check any of these other things. So it's actually going to have simpler preconditions. So if there is a monster, if it's north of the current cell, and we're at the current cell, if it has monster, then we're going to say the effect. And now this is not going to be accurate, but it's going to be helpful for planning. What we're going to say here is that the effect is that there's not has monster destination cell. And this is actually what we'll give as the goal for the goal selection part of it. So beautiful. We have melee attack action north, and let's just add it for the rest of them. So this is going to be, let's do north, south. Oh, did I miss a paren? Don't want to miss a paren. Okay, cool. All right, move south, south of, looks like we're golden. Okay, melee attack east, gonna check east of, and we're golden. And we're gonna do the same thing west, west of, etc. Now we can do the cardinal directions. Let's do northeast, northeast of, let's do northwest of, and let's do southeast, and let's do southwest. Beautiful. Okay, so we're good. So we've added these melee attack actions in there. Okay, so if we go back to our progress, separate, move, and attack, this is done. And we actually, I realized, we'll go ahead and do this now. So I'll make this C and then D. We're going to write out pddl for the has monster predicate. Yes, let's go do that now. In the gamestate.py class, gamestate.py, we need to find where we write out pddl. Get pddl string monster at, where is this function being called? Find usages. So this is being called in get pddl facts. You know, there's gonna be multiple facts for a monster, I think. So let's change this to be a list. So for fact I in self.monster, let's say this self.monster.get pddl strings, right? Then we will append fact I, which is a string. Okay, and so now monster.get pddl, if we can go, oh no, yeah, okay, yeah, if we can go back, say strings, and let's say strings are equal to, and we'll put this one in there, right? We still need that, still want that. And then what we also want is has monster, this, and we're gonna give it the pddl cell string. Excellent. So I think let's just double check that in our model we use the same has monster, and let's make sure it's defined at the top the same. Okay, whoa. Well, yeah, you know, okay, it died. Well, we'll look at that in a second. Let's just wrap up here. Okay, so we're gonna find all has monster, and we're just gonna remove the thing. There you go. Make sure that's all consistent, and then we need to go back and just make sure we move that. Okay. You know, I almost made a mistake here. So get pddl strings. want to go back and see, so where this function is being called. So if we do, oh, is my stream, It looks all funny to me. Does it look okay, the stream? On my like Twitch stream manager thing, it okay. It was like glitching out there. Cool. Thanks. All right. So the thing is, not every cell is going to have a monster. And so if this function, get pddl strings, is... Oh, this is in class monster. So actually, we're doing this in the wrong place. We can still keep it a list. That's fine. We might, because we'll probably have other things later. But actually in the cell, we want to also just say that it has a monster. So because it's the one that has this value. So then there's a pddl that writes out the get pddl facts. Okay, it's here. Right. Okay. Okay. Beautiful. If self dot has monster pddl facts dot append, we can just, yeah, this is just, we'll just do this here. Has monster and the monster name self dot, and this is just a cell, so this is just going to be get pddl name, just like the other functions. Okay, hopefully that should still work. And okay, let's go ahead and keep the agent running. So let's exit out of this. Let's hit run. Got an agent there, and yeah. Cool, fun stuff. Oh, well, we broke the planner. So, and this is because, yeah, it's actually a little bit more fundamental, actually. So, if we look at actions.py, we have move or attack. You know, yeah, I feel like attack without move. Oh. Should we just do that? Oh, let's try this. So I don't normally use this, but there is a command for this in the game. So I like it. Let's do attack without moving. So yeah, this move or attack. Oh, I wonder if it's a problem. So it was so clean before when we had, so basically these actions did correspond exactly to the names of these. And it was kind of nice. And I put move or attack here. I wonder, we should still leave it as move or attack, because you know what? It will still attack. So let's, this is strictly movement. Yeah, I think this isn't ideal because we do want to stick close to what the game, how the game is designed. So I'm actually going to remove this from these movement actions. Not this one actually. So let's go back. Let's just do. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Let's remove those. And let's change all these to move or attack. 1, 2, 3, 4, 5, 6, 7, 8. Move or attack. And let's just check. So actions.py, it still matches that. Okay. But what we can do, and so then attack without move, that's what we will name the ones in our model. So towards the end here, we have all these attack actions. So I called them melee attacks, but we will do, yeah, let's call them melee attack. So 1, 2, 3, 4, 5, 6, 7, 8. I think is it attack without move? Attack without move, yes. Okay. Okay, so hopefully that didn't break anything. And if we run the agent again, should just have some extra actions in there, basically. Getting a little bit of an error there. Undeclared predicate northwest of. We have a typo. Northwest of. Preventing planning from happening. Okay. Let's try this. Just going to reset the game and hit run again. Is it working? No? Is there another typo? Oh yeah, it's working. Okay, cool. Awesome. Okay, so we've updated the planning model. We've made sure pddl is now written out. So we've finished that. And now we're going to make the attack action have an effect if the monster is no longer at that tile. We did that, actually. Did that while we were doing A there. And now we just need to add it into the goals. And let's see if we can get it. So let's go to the agent.py class. I think it's here. And where are we? So, wow, it's really chugging along there. Okay. So I was wondering if sleeping monsters would have a special symbol. Doesn't look like they do. Okay, so what do we got? What do we got here? Okay. So for our get first monster goal, okay, this is what I think. I think this is all we need to do to change. So what's gonna happen basically now is that an agent is going to plan to move into a tile next to a monster, and then try to attack it. If it's in a tile next to a monster, it'll just generate a one action plan to attack it. So all we have to do here is I think say not has monster and then the cell. And if you think about it, this is really the state we want to be in. So it might seem like, I mean, this discussion comes up all the time with us in our research groups, but like humans don't really talk in terms of goals. They talk in terms of kind of behaviors. You say things like, I want to go to the beach. Actually, you want to be at the beach. So in this case, you're saying you want to kill the monster. Well, actually, you just want the monster not to be there. Now, if killing had some separate thing versus like the monster falling through a trap, and maybe you get gold or there's the corpse if the monster dies, then really that's whatever you want the. It's really whatever the state is, right? So do you want a corpse because you need to eat? Do you want the monster to just not be there? Now, do you want to gain experience? So in that case, you just want your experience to be higher. So the fact that you killing a monster might increase your experience, that might be another thing. But really, you just have to remember that when you're talking about goal-based AI systems, a goal is a state. Even though we humans often talk about things in terms of like behaviors. So anyway, we have this now. And I'm going to not print out this. Let's keep the string for now. And this hopefully should work. The behavior is going to be a little different, but let's see if this works. So, okay, it's going. Let's just watch it for a little while here. Ooh, unknown G value S. Okay. Excellent. So now we got a really big ASCII thing here. Unknown G value S, but I don't see it. It must not have been printed. It must print in the next state. So we'll have to wait a few seconds here. Okay. Where was the unknown G value? Wow, it really printed a lot there. Okay, so the agent was here, and then the agent moved, and then the agent moved, and then the agent moved. Unknown G value S. So there should be an S in this state somewhere here. Ooh. Well, we'll just have to wait till we encounter that again. And what I wanted to do is to print out. Okay, where are we with our progress? We added attack monster goals into the goal selection. So what I want to do, and just for testing purposes, let's go ahead and turn off all the print statements, except I basically want to say, I don't want to draw the map yet. And basically want to say goal is this. Plan length of this. And I'm going to say next action is this. And next action is this. So this is going to be useful to just see. Okay, so we got next action. Can we have the agent. Let's do agent.get. Yes, we need the agent. We need to get the agent's goal. So if we go back to the agent class, if we go back to the agent class, let's go ahead and add self.current goal. And let's have that be none for now. And self dot, we have plan. We have agent's plan. So let's do agent dot current goal. We're gonna do agent dot plan. We're gonna do length of the agent dot plan. We're gonna do next action, and then I think we're gonna do agent dot plan, and let's just say let's just say next action is equal to NA. And we'll say if length of agent.plan is greater than 2, we'll say next action is equal to plan. Now let's just see. I don't know. Are we just popping things off? Let's go back to agent.py. Let's see. So generates a plan, right? Returns a plan, and then plan equals self.plan, plan.append, and then when we get action, we're just saying plan.pop0. So we're popping off the first item in the plan. That's the next action. So it should have removed it from the plan. So the next action should be plan 0. So agent.plan 0. That's what it should be. So I think we just need to check if it's greater than 1 because yeah, let's do that. Next action. Okay. I think this will be pretty neat if this is all we're watching. And let's see, because I'm curious, I want to see how the goals are changing over time. Okay, so we have a fresh run. There's probably going to be some other things being printed out, but. And then I think we're going to get to the bonus agenda item that I was hoping to get to, where we would look at basically making better goal selection behavior. Okay, so visited cells goal is none, plan length of. Okay, well that's right. I know why that's happening. So go to agent. It was not storing the goal. So right. So here. So the selected goal is going to be this. So I think we're just going to say self.current goal is equal to selected goal. And we're going to go ahead and exit out of here. And let's hit run again. And while this is running, I'm actually going to do a bonus. Oh no, bonus to figure out how to reconnect. Yeah, so no, it's on the agenda to do. Okay, awesome. Visited 5 cells. Okay, where are we doing that visited? So I want to melee attack southwest. Okay, we got a problem here. Not has monster. Okay. Okay, cool. Plan length of 0. So just a few quality of life things. Goal, plan length, next action. Just gonna feel clever here. Next action. Okay. And about to return monster goal, not. And then melee attack southwest. Do we still have those names in the planning model? I thought we had that. Attack without move. Why is it doing melee attack? Do we have this anywhere in here? Oh, we do. There was one left out. Ah ha ha. Attack without move. That's what the problem was. All right, all right. We solved that. Let's go. Okay, let's run it. Okay. So the goal, found unknown G value. That okay, so you know, if we find an unknown G value, that's when I want to print the map. So can we do that? I don't think we can, because this is in cell. We need like a callback or something. We'd somehow need to get the global thing. So, interesting. I wonder. Well, maybe we should just be. Might be better to test that out on when we run the agent in the terminal, because then we can just watch and see everything. So let's just wait. We'll get back to this. We'll get back to this later. We're gonna work on getting the new goal selection stuff working. Okay, so the player's just trying to get to different cells. So I actually, well, let's wait till he gets to the next monster, and then. Plan going to the next level down via the stairs. Cool. Ooh, a spider. Unknown G value Z. Zombie. In a while loop. Not has. About to return goal. Okay. So, a few things. One is we now know Z is a particular type of monster. I think it's any type of zombie monster. That was a zombie spider. Okay, we got spider. And then about to return monster goal. So it's interesting. Okay. I think we're gonna need to draw the game state. That's just gonna be better. It's just gonna be better. It's just there's too much information that's being printed. And I want to just check. Okay, so. Yeah, let's see. Okay. Let's run it again. Oh. It looks like those are fountains. Okay, well I wanna make sure I get that. So this is a fountain. Okay, that kind of froze. Let's add this into the gamestate cell class. And now we know if, let's do it next to statue. Cool. And that's great. Okay. So run it again. So there's something going on with the monsters that we need to debug. Okay, so that seemed to work. Plan could not be generated. Okay, interesting. Let's go back here. See what's going on. All right. Just to check, I think open door is, yeah, this is an open door. Okay. It's lava. Okay. The right paren. What's the right paren do we have? Weapon item. Huh. I think the parenthesis just means items. Yeah, interesting. I think we should change this then. I'm gonna change this. Just give me 1 sec here. There we go. All right. Right, so this, let's refactor, rename this, and we're just going to call this has items. And this one we're going to do the same thing because I think it's also just items, because here it's a corpse and it has a right parenthesis. So let's do shift, yes, has, oh, well, you know what? Just use the same thing. So we're just going to say if self.g is in, if it's just, whoa. Let's just do that. And self.weapon item, just remove that for now. Okay. Okay, great. Found 4 non-visited cells 3 distance away from the player. Yeah, there's an issue where, so in the unresolved issues, player in cramped spaces. Yeah, so why isn't goal is player at x0, y -5. And the player is currently at -5, 6. So the agent's at -5, 6. And it wants to be at -5. So negative means it's going to go up. Oh no, does it want to go 1, 2, 3? No, if it's at 6, that means it has to want to go all the way up. But it can't. Oh, I might have a problem here with doors. So my movement actions. So yeah, if it's not a closed door, does it think? I'm wondering if it thinks it can't reach it because of these closed doors. So it should be working. Okay, when it's opening doors. I actually don't have open doors here, but that shouldn't matter. So why could it not be generating a plan? Found 4 non-visited cells 3 distance away from the player. Probably means like these 4, these 2, these 2. Oh, it's trying different goals. X4, Y5, but agent's at -5, -6. It's a curious thing. It should have, I want to go look at gamestate. And this is probably too hard to read. But let's just see if we have open doors. No, we don't have open anywhere. But do we have closed doors anywhere? No, we don't have closed doors either. Do we have any doors? No, we don't have any doors. Huh. Well, we'll figure it out eventually. All right, let's keep going. Okay. Got the agent running. Goal is to be a monster goal. Okay. Killed the goblin. Okay, so we got a run going here. I'm also just curious, does it say not, it says not lava. I was wondering if that was a problem, but I don't think so. Plan like yes, it's got a really long plan here, and it's just gonna keep executing it. It doesn't switch, right? It doesn't switch when there's a monster. Now it switches. Now it's killed the monsters. Just like a total boss. So let's see. Let's see if we can get. So add attack monster goals into goal selection part of planning. So we did this. We did this, right? So we're done here. So this is awesome. And now we want to decouple goal selection from planning. And then if the goal changes, we replan. So we'll basically run goal selection every time. Right now we're not running goal selection every time. Ooh, interesting. What happened? Coroutine game connection was never awaited. Well, I feel like that's never happened. Got an unknown value W. Oh, it died. The game died. Yeah, the agent died. Yeah. Okay, cool. So let's do future. Okay. Future. Let's get rid of this because I'm not sure about that. There's something going on, but we'll fix it later. So the issue here is gracefully handle agent death. Because it'd be nice to print out a message here rather than just throwing an error. Save some data files and stuff. So, all right, now we're on to the fun part. So now we're gonna rewrite the agent.py class. And so let's go to get action. So I think what we're going to want to do, we're going to want to make a function called def goal selection, which is going to return a goal. Returns the goal the agent should pursue right now. And there's a few different things here, but basically let's just say and do some stuff, and then we're going to return current goal. Okay, now, so what we're going to do, okay, we're going to do this. Now what we're going to do is we're going to do, what we're going to do is we're going to do new goal equals self dot goal selection. And we're going to check if new goal does not equal, ooh, that's nice. If new goal does not, do I want do not equals? Python's operators are sometimes funny. If new goal does not equal, for a while there was like the triple equals, and there's like dot equals. That's so funny. If new goal does not equal old goal, let's say current goal, then we want to plan. And so for all of them, we're just doing this. So we're just going to do this when we plan. And we'll say new goal. Let's just say old. Let's say previous goal. Didn't like old. But let's say previous. New goal. Okay. And then what we'll do is we'll set previous goal equals to new goal. Okay, so we'll do that. It really doesn't like that. Huh. Right. You can't do, what do you say, not equals? Oh my god, I've forgotten how to write Python. Ugh, I was coding in C++ this week after a long time, and I think I've just forgotten all my Python. This feels so simple, silly. Yeah, should be able to have this. Why is it complaining? Unresolved. Oh, of course. Of course. Well, let's just do this because we're going to want to track these. So just going to want to track these. And now we can just say this will solve this problem. Self.previous goal equals none. That's fine. So in the beginning, if we generate a plan that isn't none, it should trigger planning. So get action. Okay. So doesn't like my formatting. What isn't it? Doesn't like this. Function goal selection does. Oh. Yeah, I'll solve that later. Self.new goal. Okay. So these are all calling the same planning function. So, okay, basically in goal selection, now we're going to handle the ordering, right? So all this logic here in terms of what we're doing when is going to go into goal selection. So we're going to attack monsters first. So basically, if monster goal, we're going to return monster goal. Otherwise, if the player's health is less than 50% of its current health, we're going to return this. And then otherwise, so what I want to do here is that the logic for so this function is used where is it used actually? The logic where it's gonna go down the stairs. So do we not have it in here? Yeah, here it is. Okay. This, what we're gonna do is we're gonna add this here. So we're gonna say else if, so it's taken, I'm gonna say, do we want to test this every 10 actions? Yeah, sure, why not? Might be a little too, yeah, we're not worried about that yet. So every 10 actions, let's make it like a 25% chance. So if it can create a plan to reach the next floor, if there is a stair plan. So this function self.can create. So this is an interesting thing that comes up, right? When we're doing planning and execution, where we're planning just to see if we can actually reach a goal, and if so, that's the goal we want to achieve. So actually, I'm gonna say for goal selection, I don't want to limit us right now. So we're gonna return the current goal and a current plan if we have it. So I'm gonna say none so far. Or actually, better yet, I'll say none. Here I'll put none. And actually, let's just to be super clear to other folks, let's do it here. Current goal, current plan. So let's explain ourselves too here. So in some cases, deciding to reach a goal may depend on whether that goal is even reachable via planning, since we would have generated the plan anyway. Let's return it and save some work. So is that gonna automatically, there should be like an automatic way to format that, but let's just do this. Okay. Whoa. Okay. Okay, self.stairPlan. So if self.stairPlan, so there's actually no goal here, but the plan is, yeah, see, this is another hack. This is another hack. You know, to do this properly, we should have travel staircase down be an action. And yeah, this is real. This is real. So the thing now, there's a question about how do we want to model depth. So it'd be ideal to have it as an integer, but you know what? I'm gonna take a break now, and we'll revisit this in about 10 minutes. So. All right. So let's make this so you guys can see it. Okay, let's do that. And we'll be back in a little bit. All right, thanks all. All right, let's get going here. So we got some cool stuff about to happen. Okay, where did we leave off? We left off modeling depth. So I know it's not as interesting right now because the agent isn't running. But we'll just happen sometimes. We have to work on the code in a certain way for the agent to run. So okay. Well, we can just have the agent running randomly. So let's just do that. So let's run the random agent for a little bit while we work on the planning agent. Yeah, the agent died, so it should have no problem here. Okay, so that's running. So where were we? Okay, we are modeling depth. So, none? The random agent shouldn't be affected by this, right? Oh, the agent, this agent doesn't have a goal because it's random. So yes, it's because we added that little bit of code. So this is good. This is what we wanted to test this anyway. So this is fast downward planning agent. So let's just check to see if the agent is an instance of this. So that's if we care about this stuff. So basically this chunk of code we care. So if is instance, the object is agent, and I think this is fast downward planning agent. So if it is the case that our agent is one of these agents, let's do this. So hopefully this will fix that problem. I might have to go in and clear it. Maybe not. Ooh, yes. Okay, let's do that. Gonna just clear it out and let's run it again. Random agent. See if we can get up and running. Yes. All right, taking random actions. Awesome. Okay, so I fixed that problem. Now let's talk about modeling depth. So I think that we can just have depth. So for now we can just have dungeons. So well, yeah, that's right. So So I'm thinking a symbolic way to do this is we could just have a symbol for every. Could just have a symbol for every level. But if we do that, I don't know. It's a little Because we want to have this stare action. This whole process, we're iterating, right? We're iterating. We're not going to solve the whole thing perfectly right now. So what are we going to do? So we're just going to be in the dungeon, honestly, for a while. If we get to the point where our agent can go farther beyond the dungeon, that's awesome. So levels, dungeon. So I'm going to say, so place, right here in the game, right? We have place. So let's do that. So let's do place. Place dungeon 1. And, but you know, the thing is, we don't want to have, yeah, this is an interesting thing, right? Because we don't want to have like a travel staircase down action for every pair of dungeon levels. Like that just feels silly, right? So we need the dungeon levels to be different. And we want to somehow say we're going deeper if we're taking a staircase down. We're going to have the fact that some dungeon levels are less than other dungeon levels. I wonder, you know what? I think the way to solve this is we're going to have places. So there's going to be a current place like dungeon 1. So this is going to be dungeon level. And then we're going to have a predicate called deeper. And deeper is going to take one dungeon level and another dungeon level. Dungeon level above, dungeon level below. Sorry. Actually, you know what? This is going to be place above, place below. This feels like the right way to do this. Or, something that's okay for now. So place below. So now, and this kind of makes sense, right? You say you want to go deeper. So basically what I want to write, okay, somewhere down here is we have an action, and we're doing this with all of those, so let's maintain the same consistency. So we're going to go to actions.py, and there's travel staircase down, travel staircase up. So we're going to add these into our planning domain. So let's do this. Let's just make it all lowercase, travel staircase down. And we're going to have parameters. So travel staircase down is going to take a current cell. I think that's all we need. Just a current cell. And preconditions. And so the precondition is just going to be that player at current cell. And stairs at. So, sorry. Stairs has downstairs. Has stairs down. Because in English, downstairs is its own kind of noun. So has stairs down current cell. So if these things are true, we can execute this action, right? And if we do, then the effect, and remember, these effects are really just for planning. They're not, they don't have to exactly be true. So in the effect is going to be that the current place is, so this is interesting, right? We're going to have like a free variable. So if we're going to have a place and a current cell, The effect is going to be that yeah, I don't know if pddl can handle free variables. This is a really good question. So let's go look it up. We have the agent running here. Let's go look it up here. Okay, so let me actually don't want to do that. So, gotta handle my window management here. All right, what are we gonna do? So, pddl. Let's look at fast downward. Let's see what fast downward can do. pddl free variables. pddl support. Okay. Let me make sure. Let me show this so you guys can see what I'm doing. This is part of the research process. Let me go ahead and add window capture. And yep. All right. Let's move this over here for now. So still have the agent running. I want you guys to be able to read it, so let's do that. Okay. So we realized last time fast downward does not support numerical planning. Soft goals and preferences and object fluence. Quantified and conditional effects and negation, axioms and derived predicates. So this is interesting, right? Okay, so just to be super clear, what I'm trying to do here is, what I want to say is that I want to say current place, current cell. And I want to say that so far the way I've been writing this is, so we have place deeper, place above, place below. So we've been reading things like this is cell 1 is southwest of cell 2. So if we're going to do the same thing here, I want to say place above is deeper than place below. So what we want to do is say deeper Yeah, I'm really not sure what to do here. Current place, current cell. You know, I was thinking like current place, and then this is like next level place. But the problem is next level place does not exist. It's not in the parameters. Could we just put it in the parameters? Maybe. Let's not rush. Let's sit and think about this. We have travel stairs. You know, if you have any ideas, please post in chat. So I like the preconditions. Player at current cell has stairs down. If we go back to the game, so if I hide that window, if we go back to the game, right? So there's some stairs down. We know we're at dungeon level 1. We know which dungeon levels are deeper than other dungeon levels. And we could write out all that information. Yeah, it's a good question. So the reason I'm spending so much time here is because the effect of this action, I want this to be the goal. So this all started because I'm kind of just hacking the current taking stairs down goal into, actually there is no goal. Basically, I'm just saying, let's have an agent take the stairs down. And to do so, we're just going to go to a tile generate a plan that can go to a tile that has stairs, and then add an action on top of that at the end of that plan to just go down the stairs. But there's no actually goal, and there's no actually planning taking place. And we'd like everything to be goal and plan oriented. If everything is goal and plan oriented, then we can do a whole bunch of extra AI stuff kind of for free because we're using the goal planning architecture. The way I'm doing it now is it's kind of like just hard coded, like some hard coded, logic. So the problem here is the free variable next level place. Now, this is kind of where like inference could come into play. We could, yeah, ideally, such a good point. I mean, I guess a few things that come to mind. One is when the agent starts out playing, it doesn't know what its actions are going to do when it gets to its stairs. When you first play this game, you never played it before, you get to a stairs, you take it down, you don't know what's going to happen. We're not worrying about that problem because we're assuming we have some domain knowledge. That's the domain knowledge that's in the planner. So we can assume we have some knowledge. We can assume that we know that dungeon level 2 is deeper than dungeon level 1. And I guess, you know what? It's not. The effect is not that it's deeper. The effect is that, oh my goodness. The effect is that place, let's just double check our predicates here. Place, the dungeon, which is the dungeon level we're at now. And the reason I'm calling it place, right, is because here it just says place, right? This is like part of the information. So place, we have the current place, right? And I don't, this is where we would bind. Yeah, I think what is again, if we go back to what is a goal, I'm talking about things in terms of behaviors. We want to go down the stairs, but what's the goal? Well, the goal is we actually want to be at the level that's below us. So if we want to be at the level that's below us, we should have, honestly, our ideal goal is that our current place is really the next lowest place. It's really what it is. So we can just add this here, next lowest place. And now, and then we just want to say, you know what we should say, actually? We should say connected. Because really, stairs connect levels, right? So we should say connected. We'll have to add this predicate connected. We should really say connected current place. Really, the current place is connected to the next lowest place by these stairs. By this current cell, right? This is one of the connections between levels. I think this is totally fair, right? So let's have all these. So we want to say that they're connected. Yeah. So if the player's at a cell, the cell has stairs, and those stairs are connected from our current place to the next lowest place, then and if our goal is to be at the next lowest place, this is a good action. This is what we need. Did I not close? Yeah, I think, and this closes the top level file. Yes, okay. Gotta double check your parentheses. So I feel better about this. Now, the parameters for this action, travel staircase down. Current place, current cell, next lowest place. I don't like the fact that there's next lowest place is needed. Yeah. Maybe there's no way of getting around it, though. Let's so I'm just gonna go. Let's go double check here. So, just gonna go ahead and show this again. They had mentioned here. This is where the pddl specification is. So actually, if we just type this, is this it? Maybe this is it. Okay. Page 63 of this has 64 pages. It's not actually page 63 because that would be citations. That's not actually helpful. So A5, here's the list of all requirements in PDL 2.1. Strips, typing, negative preconditions, disjunctive preconditions, existential. So existential preconditions might be what we need. Allow exists in goal descriptions. Well, this would be pretty cool. I think that's what we need. Does fast downward support it? Okay, all aspects of numerical planning, soft goals and preferences, object fluency. We don't have soft goals, right? These are hard goals. They're goals we have to achieve. Limitations. Universal conditions and preconditions, effective conditions, and the goal are internally compiled into axioms. Okay, guys, this might work. Wow, I'm going to be thrilled. So I actually haven't written a planner model with existential preconditions. So this is pretty neat. Yeah, wow. Well, so I think in our domain model, what that means is we can say existential preconditions here. Let's make sure we spell it right. Existential preconditions. Wow, this is going to be really awesome. Okay, we got existential preconditions, but I want to double check, right? So we should proceed carefully. Don't rush into things. So planning adjustment. I want to go to this editor. Last time we were able to import examples for fast downward. So okay, I bet the agent died. Did he die? Yes. Oh no, terminated due to an error. Yeah, I don't know what that was. Anyway, let me just. So here you're seeing the admin, which I haven't shown. Not the admin, but this is where I clear out the agent, and then we can just run it again. And let's just have that going in the background. Okay. So now import fast downward all problems suite. Let's do this. Oh, cancel. Okay, no, this is right. So let's look for existential. It's always so nice if you can find an example, right? So just to make sure you get the syntax right, everything else right, etc. So is there something with existential? What'd they say? Existential preconditions. Yeah, that's what we want, right? Next lowest place. We want existential preconditions. Hopefully. Well, can I do a control F? No. I don't, oh, no. Okay, let's see if I can do control F here for existential. No, there's no existential. Wait, did I spell it wrong? Maybe I spelled it wrong. No, I didn't spell it wrong. Okay, let's Google a little. Existential preconditions fast example. Let's see what we got here. Existential preconditions. What is this? This is PDL 1.2. existential preconditions. Requirements exists allows for the use of exists in goals and preconditions. Exists is essentially an additional parameter which we don't need apart from a subset of the conditions. For example, typically exists is not used in favor of just adding an additional argument to the action parameters. Right, that's what I had done. I had just added an additional argument here. But, you know, we're trying to be clean with this. But do we need to... Okay, if we don't use the exists, right, then we need the state to have the next lowest place and the current place. But if we say connected anyway, I think that's fine. Maybe we don't need existential preconditions. Maybe that's fine. We're just going to have this fact connected, which we're going to have to add into the pddl. Let's just do this. Okay. Hopefully we have found the end of that rabbit hole. Okay. So what do we got? You guys are back watching the agents, which is, you know, just always entertaining. So, okay. Let's go off and do this. What do we need to do? We need to add some stuff to the gamestate pddl. So, first of all, now, you know, okay, let's go to gamestate.py. Okay, let's find where we're writing out pddl. Okay, this is one spot. Get pddl facts. Where are we? We are in a cell, aren't we? Yes, this is the cell class. So get pddl. I want to find a lot of pddl calls there. Get cell map pddl. So where's this used? This is a better place to jump around. Get pddl current state. Or wait, where are we? Is this just gamestate object? This might just be gamestate. Yeah, this is just gamestate object. Okay. Excellent. So, ideally there should be a file. Should really do that. Write pddl current state to file. This is where we're writing everything. Init and goal. So, I'm going to have to tell you what the best way of doing this really is that we add in a model here. So we should really add in a new file. And this should be, what should this be? This should be, it's like common knowledge, general knowledge, right? So general DCSS knowledge.pddl. I don't know. Maybe that's not the best one. Okay. And it's not going to be strict pddl, but it's generally going to be the syntax of pddl. So what we're going to do here is we're just going to say, so I think this is what comments are in pddl, right? Yes. That's the comment. Okay. So this file contains all of the general pddl facts that don't differ between game states. So, for example, the fact that certain dungeon levels are connected to others, we're going to have here. So, if we go back to our domain, right? So we have connected and we have deeper and we have place. So possible places is not going to change, but deeper and connected. So, okay. So basically we're going to say dungeon. Okay. If you look at the, okay. So you see we have place here, right? And we're at dungeon 1. So that's what we're going to do. Okay. And so we're going to say, and this is, Making this API, this is a little bit of, just kind of boring work. We just got to encode a bunch of stuff to support AI agents, Later, we could try and take an approach of just, a very knowledge-free approach where we just, collect images and let an agent run. But there's so many cool, interesting AI problems to be looked at if we can get a pddl and we can get a vector-based representation. So we just have to collect some data here, and we're gonna do that. So we're gonna say that dungeon 1 is a place, and dungeon 1 is connected to dungeon 2. Is this what we have? Current place. Okay, you know what? We're gonna drop this current cell. That was kind of a nice thing, but that's game state specific, and I don't know if that's needed, to be honest. Yeah, I don't think it's needed. It's kind of extra. So we're gonna have this, and let's go to the wiki, and sometimes we just got to do this stuff. So let's go to the wiki. Let's do crawl wiki. All right. Crawl wiki. So spoiler alert. Just be careful if you haven't. So dungeon map branches. This is exactly what we want. All right. Dungeon has 15 levels. So we know we're going to have 15 of these. So we got like 6 so far or something. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Need 2 more. 14, 15. And I'm going to try and be clever about this. But let's just see it. Oh, nope. Sorry. Can I be clever about this? Yeah, I can be clever about this. Okay, check this out. No. Whoops. Okay. Sometimes you just do it manually to be fine. But okay, if we do all these, right, and then we go here, we do Control C, and then we go up 1, and then we do this, Control V. It kind of worked. Not perfect. I do love this multi-select capability for PyCharm. If you don't know, so if you use PyCharm and you use the default key mappings, it's Alt-J, and it's just so convenient. 13, 14, 14, 15. 15 is the last one. So 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 11. Okay, it all looks valid. Okay, so we know those levels are connected, and this is just a one-time thing we got to do. The temple. So we don't know what level that's connected to. But we do know that's like a special entrance, so we'll have that somewhere. We're not gonna worry about that. Okay, so now we have layer. So let's do this. We know that we're just gonna do layer 1. Oh, actually, we can just, layer has 6 levels, right? So let's just do this and make this layer. Beautiful. Okay, so we got the layer done. Now let's do the swamp. So we know that the swamp is 4 levels. So swamp is 4 levels. We got the shoals, that's 4 levels. I mean, it'll be great once we have an AI agent that actually gets to these places. Oh man, I remember the first time I got to shoals. I was so excited, and Pretty sure I didn't make it out alive. Man, once you get to the swamp, the shoals, the snake pit, the spider's nest, there's so many spiders. Oh my god. You guys that are watching, you've only been seeing just like a few monsters. There are times your entire screen is filled with monsters. It gets crazy. Hope that didn't spoil anyone's interest in there's no spoilers there. Okay. We got shoals. Let's do snake pit. So all right, snake pit, shoals, snake pit, snake pit. Let's do spider's nest. Spider's nest. And then we got the slime pits, which is 5 levels. Slime pits. And let's get another one there. All right, a little bit of knowledge goes a long way. It's going to help us plan all over the map and do really cool things. So we got the orc mines, which there's just 2 of them, so that's great. Orc-ish mines. Try and keep it close to the similar names here. 1 and 2. And then we got the elven halls. There's 2 of these. Ooh, let me get this one. Elven halls are connected. And the vaults, 5 levels. Also, what's cool is that you may be asking yourself, well, hey, isn't AI so sophisticated these days? Why can't you just learn this? Why can't you just learn this? Well, even if we are going to learn it, right? The cool thing is that if we have this, it serves as a really good baseline, right? So we can see how well does it do against some amount of expert knowledge provided. And it's not like we're not recoding the entire game here, but we are adding a little bit of manual knowledge, you know? So it is non-trivial. I don't know. There's this big debate going on in AI right now, whereas like, is the time and money and resources to collect the data and label the data and train and retrain and test the machine learning algorithms, does that save you more than having to encode the knowledge manually? I think in a lot of cases it's obvious, yes, but it's not. You can't minimize the amount of effort that goes into collecting and maintaining and cleaning the data and training and all that stuff. So, okay, we got elven halls. We got the vault. These are the vaults. So we want to do the vaults. Ooh, vaults 5 is always a fun time. All right, and then we got vaults, and then we got the crypt, which is 3 levels. So we get the crypt. Cool, and then we got the tomb here. And then we have the depths, which is 5 levels. Depths. Okay. And then we have the abyss. Oh, the abyss has levels. Oh my god, the abyss. It's going to break all the AIs. If you don't know, the abyss is like an infinite level. It just like is constantly shifting. That's just gonna be wild. Okay, abyss. Oh, what am I doing? I'm breaking the. Okay, here we go. Sometimes my brain just shifts to autopilot. Okay. We have hell, which is just 1 level, so we're not gonna need anything there. And we have 7 levels for the different levels of hell. So let's use these. I know you're probably thinking to yourself, you're missing some things, like hell only has 1 level and it's available from the depths. But yeah, I think for all the special entrances, we'll have its own separate fact. So this is mostly just for taking stairs down. And if we have taking an entrance as different, I don't know. It's not going to be perfect, right? Not going to be perfect. But we just want it to be functional. So I don't know. I don't even know how you pronounce this, but we got this. And then we got Gehenna. Believe it or not, I've actually gotten a character that far in this game. If you find the right gear, you can get really far. Okay, that's obvious. All right, Tartarus. Awesome. And the Iron City of Dis. I don't know if I've been there. Iron City of Dis. Then Pandemonium has an infinite number, and Zot. So we'll just end with Zot here. And Zot only has 5 levels. Okay, cool. So there's about 102 facts that are going to be constant everywhere. This will allow us to meet the preconditions and have some information. And, you know, really, if we can get an AI agent to go through the first 15 levels of the dungeon, that's going to be awesome. And then by then, we will have made some other progress and stuff. So, and maybe even by that point, we'll have a reinforcement learning agent. And we're just care about vector representations, and we don't even necessarily have to worry about a pddl version or whatever. Okay, so let's just double check. So we have the connected predicates down. Has stairs down. This is information in the game. Place is in the game. So this is all the general knowledge I was thinking we would add right now. Let's go ahead. I think we're finished with this page. So we still got the random agent running, and let's okay, so now what I wanted to do is add this into the pddl writing code. So if we go back to gamestate.py here, right? So we're actually going to read in the data here. So read in common knowledge facts and put them first. Okay, something happened with our midkit agent. Let's just reset that. One thing at a time. Hit run. Oh, it's probably gonna break, actually. Maybe not. Oh no, it's the random agent, so this shouldn't break it. Hopefully. Okay, it's working. Awesome. So what we're gonna do is we're gonna open this file. So with and I think we have some code. I always have to look up the file IO code. So where do we have this? We have this. Yeah, with open this. This is what we want. This is exactly what we want. Well, not exactly, but okay. So we want this, and let's have like not magic values. So self dot general knowledge pddl file name is going to be equal to So if we go back, yeah, it's going to be equal to models slash fd temp files slash this. Nope. Nope. Didn't copy. Copy. Okay. It's going to be equal to that. That's the file we're going to open. So now we can take this, go back to where we were, and we can enter it here. Just going to read it in as F2. I don't know. And now for line in f.readlines, sorry, F2 dot, ooh, not insert yet. If line dot starts with this, ignore it. It's a comment. Then all we're gonna do is we're gonna do pddl string plus equals, plus equals line plus new line. Is there a new line already in it? You know, let's just make it clean. Let's strip it, and then that way we don't have to worry about it. Okay, I think that's golden. I think that's everything we need. So, okay, we have now added common knowledge into the planner domain file. So what that means is now we should have connected. So this will say that dungeon level 1 is connected to dungeon level 2. So we can have a goal to be go to dungeon level 2. And now we just need to make sure has stairs down is a fact that's also has stairs down and place are being written into let's just go ahead and so so to do this, basically what have we been doing? So we want to make a goal, make everything goal oriented with a goal selection function. So to do this, we are needing to make traveling down via stairs goal oriented. And to do this, I don't even know what symbol to use here. Let's just use like a star. To do this, what we need to do is write an action model for traveling stairs down, right? And then we also need to write an action model for traveling stairs down. What else do we need to do? We needed to add new predicates to the pddl. We need to add new common knowledge to the pddl. So we finish this, add the new predicates to the pddl from gamestate. That's what we're going to work on now. And then if we do that, we'll have finished this one. So, okay, just to orient ourselves. Right, so we're going to do has stairs down and place from gamestate, right? So let's just first check. So cell, got the cell class. And do we have has stairs down? So if has stairs down, is this being written to the pddl? That's what we want to find out. So I guess that is cell information. So pddl in the cells, in the cell. Sorry, that must be dizzying to watch. Okay, here's cell information. Get pddl facts, right? For a cell, yeah. So we're not getting cells down. Okay, we need to get cells down. So if self dot has stairs down, then we are going to, and let's just make sure it's consistent here. Has stairs down is what the fact's going to be. So let's do that, and we same style. Let's just go ahead while we're here. Might as well. Doesn't hurt anything. Whoa. Make has stairs up, right? We're not using it yet, but we might. Gotta have a fleagle in there, right? When things get hairy. Okay, has stairs up. Now we also need place. So let's go back and see if, okay, well, let's find it manually. So in cell, or yeah, I don't think it is cell. I think it's game state. I think it's game state. So player place. There we go. There we go. You know, I want to print out what this is, player place, because it needs to map, needs to match exactly. I think it's literally going to be dungeon:1. So where is this being set? Find usages. So you know what I'm going to do? I'm going to set a breakpoint here, and then we'll be able to investigate. So we're going to stop running the program. Let me reset it here. And place should be something we get from the very beginning, so it should be easy. So set a breakpoint. Let's debug it. Might be another breakpoint that gets triggered. Okay, player.place. What is it? Self.player.place. It's still empty. Okay, let's just go. Wait till we go again. It should get triggered again. Agent sending actions. Oh, it doesn't get triggered, huh? Well, that's disappointing. That's quite disappointing. I wonder why that is. So I think I have code in here saying if K doesn't match any of these. Warning, unknown player datum. So that should trigger. So let's go comment out this K equals place, and we should see a complaint. Oh, yeah, no, it should be that. It should be that. So okay, let's try this. Close. Let's just run it. Okay, let's run. Don't even need to debug it or anything. It should just, yeah, place dungeon. Okay. Huh. Does it say it's somewhere else too? Oh my god, this is insane. Wow, okay, we gotta investigate this a little bit. This is important. So, okay. So I'm also gonna print for I know, it's terrible. Actually, that's all we need. Okay. Let's do some debugging. Isn't it the best? Place, dungeon, depth. Place and depth is the combination. Okay. So what's frustrating though is that this, if we move to a different planning paradigm that can handle numbers, it would solve all these issues we have. Because for depth, we could just make it have, just say the depth is equal to the current depth plus 1. So that would solve the whole extra knowledge we added in. But yeah, just, one step at a time. But still, I need to double check here. Okay, let's let's run it. Let's debug it again, right? Added a break. Yeah, let's debug it again. Okay, self dot player place. It is dungeon. Okay, cool. Okay, cool. So that's working. So we're good. We're great. It's set. Okay, awesome. Let me just reset it here. Okay, we're good. We just run it. Just run it. Okay. Player place. What do we need to do? We need to write it out to the web server. Oh, I'm fading a little bit here. So, right, game state, right, we're writing it out. Okay, let's go back to where we were. Hopefully I can find it just by zooming through here. Nope. Player place, player depth. Okay. That's fine, that's fine. Game state where we're writing out the pddl. It's so great if we can finish this up when we use it. Okay. So, right, we have all that. So it's in game state, right? So when we're writing to the pddl, come on, where are we doing this? Okay, here we go. I think we could just fact strings. So where am I getting everything? So get player, get pddl current health, gets current state player. Put all player fact information here. Okay, so I think we want to do that. So I think what we want to do is we want to say player fact strings dot append, and we want to give it place. Okay, you know what? To be consistent, we should change this to be... No, we can't handle numbers right now, so we're going to ignore all that. I was going to say we should separate place and depth. We should remove place from depth and have it be separate, but let's not do that. So we're going to say place. And this is going to be this underscore this And what we're going to do is we're going to do self.player place dot lower dot strip. And we're going to do self dot player depth, which is this one. Okay. Place, and then what do we need has stairs. I think we already did has stairs. So if we did has stairs, and we have has stairs, we have connected, we have place, and I think we want to say, right, place current place, then I think we're good. I think we're good. Wow, this is awesome. Okay. So let's just see if it all breaks. Let's go. Let's go to the agent, main web server, and we're gonna make it be the planning agent. And actually, sorry, one more thing we gotta do. We need to go in here, and now we can finally say in goal selection, right? We can say else if actions taken so far and random this, then this is all we need to do. Then we want to get to the next lowest place. So yeah, we're getting to a point where we almost want to have a knowledge base in the agent that we could query, but we don't have that for now. And this is going to be hacky. I hate to do this, but just for the sake of iteration, choose a lower depth for current branch of the dungeon. So what this means is if we're at dungeon level 1, we're going to try and go to dungeon level 2. If we're at hell 1, we're going to go to hell 2. If we're in swamp 3, we're going to go to swamp 4, kind of thing. So current place and current place is just going to be, actually all we're going to do, so next lower, let's do lower place. Lower place string is going to be equal to self dot current game state dot player place dot lower dot strip. Actually, let's do the same thing. Self dot current game state dot player depth. Boom. Lower place string. And all we're gonna do, this is glorious. Okay, we're still actually gonna want to. No, why do we care about reaching a plan? If we've seen it, we should be able to plan to it. Let's do it. Let's forget all about this. And let's just say we're going to return place we're just going to try this. So if we go to our planning model, place is all we need. We just need to say it'll just try this. We have places being connected. We have our current place, stairs down in the current cell. I think we should be good. Famous last words. So we were in agent.py. Let's go back. All right, agent.py. Goal selection. Goal selection. So if this is true, you know what we're gonna do? We're gonna, because of these nested if statements, I don't want to get into a problem there. So we're gonna do this, and we're gonna do that, and then okay, that should work. Otherwise, we're gonna get, yeah, that should work like before. You know, we removed the whole needing to plan thing there. So let's see. We're gonna remove this current plan nonsense. So current goal, returning the goal, returning the goal, returning the goal. Don't need this. All right. Now back to here. We call goal selection every time. If the new goal is not equal to the previous goal. Oh, but you know what? You know what? It's really the goal type. It's really the goal type. I'm probably writing too much code at once without testing things, but sometimes you just got to do that. It's really the goal type, and I really feel like, yep, we're gonna do it. Current goal type, and we're gonna have this be an empty string, and if it's here, we're just gonna say monster. If it's here, we're just gonna say heal. If it's here, we're gonna say stairs. And if it's, let's say stairs down. And if it's here, we're gonna say actually, so I'm just thinking now. So if self.newGoal and self.newGoal does not new goal type, self.newGoal, self.newGoal type, and you know the issue, the why I'm doing it this way. So if we have self dot, if we don't have the type of the goal, so we don't want to have the exact goals, right? Because if the agent's going to generate a goal to reach a tile it's never been to, and then it's going to just one step later pick a different goal, it might pick a tile that's like one step farther away, and that's just a little inefficient. It's mostly, the main reason we're doing this is that like we want an agent to switch goal types if it's important, right? If it's planning to just travel somewhere for exploration, but it sees a monster, that's a big deal. But you don't want to constantly replanning just because it decides there's one tile farther away that it can get to. That's just, we don't want to do that. So I'm just gonna make this. I'll make this none as well. Get first monster goal. All right. Okay. Can remove all this. So honestly, I don't think we need to do all this anymore. That was just some hacky stuff before. I think we just remove all that code. Oh, it's so much cleaner. I knew it would be so much cleaner when we did this. So let's just return a random action here, honestly. Let's go to the random action agent. Let's do this. Let's make it a function though. It's a little cleaner. Get random simple action. Beautiful. And we can call this function here just so the agent doesn't like freeze and do nothing. Next action equals self dot get random simple action. Okay. Okay, it's gonna break. Let's run it and see where it breaks. Okay. Ooh, wow, a lot of doing stuff there. Okay, well, yep, it broke. No such file or directory models, ft10 files, general dcs knowledge.pddl. Oh, it's not an ft mod. It's not, yeah. Yep. Because it's not a temporary file. Okay. Let's rock and roll. Fastener planning agent object has no attribute previous goal type. Where are we trying to do this? Got it. Yep. Actually, we just have them both. That's fine. Okay. Is it gonna? Yeah. Let me reset it. Okay. Cannot unpack non-iterable none type object. Is it just that? Line 366? No. I'm not actually using that anywhere. That's fine. Monster heal stairs down. Oh, here we go. Oh, current goal? What's current goal? Does current goal ever get set? No, it doesn't. So let's just not do that. Okay. Okie dokie. Working out the kinks. Undeclared predicate has stairs down. Okay. So that's an issue here, has stairs down, which means in game state, we are not writing it out like that. Control find has, let's do stairs down. Well, /r/n. Oh no. Ooh. Really? Should I just... Has stairs down. Ooh, where is that? I don't... Oh. I think I know where. This is not being saved with no. Sorry, not this one. But fast downward. This is not being saved with Unix line endings. Okay, this is an issue. LF line separator. No, that's what I want. Yeah, I think I want... Wow, really? Let's just... is that the issue? Undeclared predicate has... Oh, no. I think it's up here. Yeah. We don't have has stairs down. Has... That's all. Hopefully this is all. Yeah. Cool. Hopefully that's it. Let's try it again. It's looking like we will not get to the bonus agenda item today, which is the making so the agent can reconnect to an existing game. Ooh, plan goal none. Plan length. Interesting. Well, it's moving. It says goal is none. Why is it saying printing out goal is... Oh, I know why it's printing that out. It's printing that out because I'm not actually saving it. Self dot current goal equals self dot current goal is equal to self.new goal. That's right? Because somewhere in main, right, we're printing out goal is this, and it's the variable agent.current goal. Yes. Right. So that was why that wasn't printing out. And previous goal type, current goal. Why doesn't it like that? Is it just, it's too close to formatted 2 lines? Yeah, why is it complaining? Oh, it's not in, oh, really? Got it. Okay, that's why it's complaining. Okay, cool. Ooh. Okay. Self.plan. So if self.plan, and hopefully that'll take care of this error here that we got. And, you know, just to double check in the main function. Let's just double check that. Okay. You know what? Let's do this. There we go. And, whoa. And if this is not the case, okay. Luckily, these are just kind of small kinks. Hopefully everything's working with the pddl, but let's keep running it. See where we can get. Oh. Wow, what is going on here? Well, it's doing something, but it keeps saying the goal is none. Why does it keep saying the goal is none? Self.current goal. Yeah, I'm just not. Self.current goal, and that's what I have in the main, right? Agent.current goal. So confused. We're gonna solve this. We're gonna solve this. Yep, I'm gonna debug it here. Oh, no. Actually, gotta reset. Next time we are absolutely adding that feature to reconnect in the middle of the game. Might take the whole time. Okay. Is it debugging? Wow, it's not even hitting that? Oh. Oh, because it starts out. What is self.new goal? Not has monster. But why is it not? Oh. Why is goal selection returning none? Oh, I'm not returning the goal here. Oh my goodness. Oh my goodness. The whole point for adding the goal types. Okay, fine. If you're happy not having that, I'm happy. All right. All right. I think we solved it there. We can run it normally now. It's a lot of plants. Let's honestly go ahead and save this. Copy. And what are we doing? Okay. Plan length, awesome. 6, 9, 7, 8. Okay, something weird is going on. The goal isn't changing. That's weird. First of all, let's go back to gamestate, and I think Okay, let's reset this. Okay, goal was being funny. Did we update? Yes. Okay. So I think that I want this to be here. Oh. If self.previous goal starts out as none. Yeah, this should work. That should work, I think. Hopefully that was the only problem. Okay, let's run it again. No plan. This is tough. We have glass walls here. And it should recognize it as a door, but let's see. Why was that complaining? All right, we got a wall of text there. Not has monster. Plan length 6. And then G value B. Huh. Let's just try it again. This looks more promising. Player at 1x. Cool, executing a plan correctly. Awesome. No plan. Taking random actions. About to return monster goal, not has monster. Why? Oh. Oh no, yeah, it's always trying to attack monsters first. That's fine. You know, I'm curious. It did look like it executed a plan correctly there. So let's go. Okay. So the agent starts here. This is the agent. And there's no monster, right? So the goal is player at x -6, y 7. Agents at 0, 0. Plan length is 6. Next command is to move southwest. So then we see the agents at -1, 1, moving southwest here. Plan length 7. So did it generate a new plan? The goal is the same. So it should not have generated a new plan. That's weird. So that's so weird. It's so weird. I think I'm gonna have to call it. I was hoping we would get through it, but we did make quite a bit of progress today. So decouple goal selection from planning. So we did this. we did this, and then I would say test goal selection this we left off, right? So I'm just gonna left off here. What did we leave off doing? Issue was that, what is the issue? Issue is that the agent, yeah. Well, the first issue is just that the agent seems to be replanning for the same goal, which shouldn't be happening. So I want to double check that. Just, I had a thought. So self.newGoalType is this, and self.previousGoalType, is that being set? Yes, it's being set. So I feel like we should debug this. Let's do one more. I know I said I was going to call it, but I'm just going to try and do one more. Let's run it in debug mode. Just so curious to see what's actually happening. Okay. Self.newGoal is player at cell negative x3, x negative 3, y negative 7. New goal type is explore. Okay. So player is at a different location, but the goal type is explore. So if we step over, okay, it doesn't get triggered. So you know what? I'm gonna change. Whoa. Can I not do that? I can't. Oh, because that's, yep. Okay, I want to do the breakpoint here. Let's continue. Okay. Well, so actually this looks like it's working. Plan length 9, 8, 7. Yeah, the plan is being funny. We need to print. Well, okay, so it found a monster and now it's switching. Okay. Plan length 11, plan length 8, plan length 11, but it's not being triggered in here. Is other planning happening? I think other planning is happening. I think self.plan is being called somewhere else. Yes. Oh my goodness. It's being called in goal selection. Terrible. Anywhere else? It's being called anywhere else? Oh, I knew we were so close. This is the function planning. No, that's fine. Self.plan. Okay. Okay, this might have solved our whole issue. Cool. Okay, let's see what we can get. I did like the way we were debugging, so we could see whenever it changed, it was switching goals. So I'm going to keep this here, and I'm going to run in debug mode again. Now, hopefully this should be a bit more consistent. Oh, no wonder it kept replanning. All right, self is new goal player at, we're exploring. Okay, so we're going to explore. 7, oh no plan, taking random actions. What? Why is it taking random actions? Player at cell x-2, y7. It's all just regular tiles. Plan length is 6. Okay. Plan length. Player cell at -2, y8. Why did that change? Why is that changing? Somehow the goal is changing. We don't mean it to. So that's got to be... self.new goal. Okay, we're going to exit out of that. Self.new goal is what we're looking for. But where else? Okay, here and here it's set to none. Here and here it's selected. 5, 6, 7, 8, 9, 10. This is the only place it's working. And then goals is equal to self.new goal fast downward. So confused. Why? Okay, well. Okay, I want to use this and print out what's happening. So close here. Okay. And then in the web server, I want to print this out. So goal type okay. Let's do it. Let's just, well, let's debug it again, but just because that was so useful. This is a strange level. Okay, planning. Oh, there's a problem with my water. Yeah, this is because I can't find. Yes, and the ASCII, it's not showing the difference between water and deep water. That's kind of frustrating. Oof. That's an issue. That is an issue. I think in the ASCII art in the terminal, it's actually different colors. So I don't think it's played black and white. Anyway, let's do it again. I'm going to add that into this shallow and deep water can have the same symbol. Yeah, okay. Okay, let's see what's happening. So console, debugger, self. Well, let's just hit play for now. Wait, what? Well, now it's, oh, I think it just can't find. That's so weird. Yeah, something's going on, I think. All right, this might be the last one. Okay. Plan could not be generated. Really? But I'm so surprised. You know, I wonder if just debugging, it just doesn't like debugging because of like server messages and stuff. So let's just run it normally. Because there is some asynchronous communication happening, I believe. Although it should just be happening between sends. Yeah, I'm not sure about that. Okay, plan length. Huh. Why is that? So, plan length 6, type explore. Plan length 5, same goal. X -8, -5. No, the goal is different. How is the goal different? I don't understand at all. Is I don't understand. The goal is changing. -8, -5, -2, -8. Plan length of 6, plan length of 5. And now the goal is different again. Oh, I know what. No, actually, no, it doesn't make sense. It doesn't make sense. So, if we go to agent, come on, where's agent? I'm in agent. Okay. If we go to goal selection, first it tries monster, then it checks health situation, then it tries to go to stairs. Otherwise, it does self.random non-visible. Okay. And then it returns this. Okay. So, why is this being changed? I know why. I know why it's being changed. It's not actually changing for planning, because it's not calling planning, but it's changing it here. So, this shouldn't happen here. This should happen here. This should happen here. Because all the goals are changing only if something new happens. So that should fix it. Okay. All right, let's try this. Let's try this. And I don't want to. Well, yeah, let's just continue. Okay. Okay. Some stuff happened. Why? Why did that happen? Okay, we started, Eden said 0, 0. Goal is be at x2, y4. That's the goal. Plan length is 3. Gonna move southeast. All right. Plan length is 2. The goal is the same. Goal is the same. Plan length of 1. No next action. Move south. Okay. The player's here. No goal, no plan. So I think something is happening with the random exploration. And it's just not, there's something that's just not liking. So we had written this function before. Can create plan to reach next floor. Oh yeah, no, okay. This is the one I'm talking about. Because it is calling this. Found 3 non-visited cells 6 distance away from the player. So why is it not returning that? Farthest away cells. That's so funny. That's so funny. Okay. Let's try it again. Why is it not? Okay, I don't know what's going on there. That's so weird. Maybe I clicked in the wrong browser or something. Player at cell X1, Y6, no plan. That's so weird. What does gamestate.pddl look like? Did we mess up something? Init connected. All of these. Oh no, these are all cells. Okay. Well, let's change that to be a little nicer. Oh, I think we need to say that they're places. Yes. Yes, yes, yes. We need to say that they're places. So what I'm going to do is I'm going to take all of these. Actually, what I'm going to do is I'm going to take everything. Yep, I think, wow, this is one issue. So, okay, line 102. And then line 102. Okay. I'm going to replace this with place. And I'm going to go how do you, I know there's a command line shortcut to delete a word. Delete word in PyCharm hotkey. Delete to word end is control delete. So if I come back here, I should be able to go over one and hit, I should be able to do, this is cool, I'm learning some shortcuts here. Control shift, yes! Now I can move over one space and then I can do control delete. And it should delete that word. Amazing. Amazing. Backspace. Awesome. So we have all these places. Now this isn't, we're missing one at the end of each of these, so I'm just gonna do that manually. One day we're gonna have software that can figure out these patterns as people write them and just be like, yo, let me finish this for you. And it's gonna be great. You kind of have things like that in Excel, but it's not quite there. Or it's not quite general enough for other places. So. Oh, I think I'm a fool. I think I'm tired and I should stop. We don't actually. Yeah, while these are places, maybe we do need this actually. These are places. It's just that I think we do need this, and we need to say, because these are places that exist, but they aren't the player's current place. So, because like we have to say all the cell objects. So, which is kind of similar to what we're doing here with places. So, yeah, I think we do need this, which is good. We figured it out. And is this the end? I think this is the end. Sat 5. Yeah. So we do need this. Yeah, I just want to do a few more things. I think we're gonna have to call it. Thank you all so much, everyone who stopped by the stream. I really appreciate it. Hope you got something out of it. We will finish this back up. I'm going to go ahead and just push this. So let's go ahead and just do... whoa, whoops. Yes, thank you. I did not I accidentally pressed enter there. Just want to update this, left off here. Also left off adding individual places in the general knowledge file. Next time, need to make player place unique. Can't use place predicate. Okay, that'll be to serve as just a reminder where we're at next time. And yeah, hopefully eventually we can get to this too. So let's do that. Did we add any files we need to add? I don't think so. These are both temporary files. So excellent. Well, very productive evening. We are going to commit this. So C contribute Twitch stream progress log for changes to code. Left off debugging. This might not be the best style, but I personally kind of like to do this with my Git messages. Left off debugging planner and goal selection in planning agent. Okay, I'm gonna push this. Awesome. All right. Well, thank you all so much. And we're doing this every Thursday, 7:30 p.m. EST. Just want to make sure the files got updated. Yep. Okay. So we're great. Hope you all have a good evening, and see you next time. Take care.